Mammal brain, it has 6 layers of neurons in the neocortex, just like all mammals, right?
That's right.
You'll notice, though, that the hemispheres don't split. They don't have a big falx that goes down the middle like we do. Okay? And you notice that it doesn't have a strong lateral sulcus or fissure here differentiating the temporal lobe. You can't pull the temporal lobe out and look down in there at the insula, okay? Because it's pretty solid right there, okay? But this is the temporal lobe right here, okay? Frontal, okay, and then parietal, occipital in the back. Their visual centers and everything are set up just like ours are. The cerebellum here, okay? You'll notice that the shiny stuff on top here, okay? What membrane do you think that is? Arachnoid, the shiny one, right? The dura has been taken off. Okay, that looks more like a piece of wax paper.
So
Okay,
those are the veins right there, and
Yeah.
so when one of those bursts, that's a subarachnoid.
subarachnoid bleed. Okay, you can pick up the arachnoid like this if you poke through it. Okay, come on, there you go. And I can lift it up. See, now I'm underneath the arachnoid right there. But if I peel it away, you'll see that the real brain there is not quite as shiny. That's the pia.
That's the pia, okay.
Okay, and you can't peel that off. Okay, it's just it's intrinsic part of the brain tissue there. Okay, and spinal cord here. You'll notice it comes out the back instead of the bottom because it's a 4-legged animal. Okay, and if we just flip it over now, something you should be able to identify on the human brain, if you see the ventral view like this, are the olfactory bulbs. This is for the sense of smell. You can see the tracts here, okay, the olfactory tract. Once it's part of the brain, it's a tract. It's no longer a nerve. Okay. The actual olfactory nerve is coming out of the bulb and going through the cribriform plate and into the respiratory mucosa. Okay, so it's very short. Okay, but this is the bulb and then the tract. You should, on a human, you should be able to pick out the optic nerves. Okay, this is the chiasm where it crosses over. Okay, right behind that is the infundibulum where the pituitary gland would be. Okay, and then right behind that, okay, is the mammillary bodies. The mammillary bodies. The corpora quadrigemina, remember, is sort of on the back of the brainstem. Okay, it forms the roof of the cerebral aqueduct, remember? So we'd have to turn it over and then look right there. Now you can see the corpora quadrigemina. Okay. You see those lumps?
Oh, okay, okay.
The little bumps. And if I look further right up inside, pull this down a little bit more, you see a little lump in the middle?
Yeah.
What is it? Is that the...
Oh.
That's sitting right up just by the corpora quadrigemina. Remember, up on top, you need to look that way. Okay, the one right in the middle there, that's the pineal gland. Okay, it sits on those pictures we've looked at so far. It's right up on top there. But there's the 4 lumps: the superior colliculus and then the inferior colliculus down below. Okay, they have a pretty good developed colliculus there for visual reflexes and things like that. So, all righty. The rounded area here, you know, the pons, right? And then this area here, medulla oblongata. Your peduncles will be up in here where the fibers are starting to spread up into the hemispheres. Okay, don't worry about pointing out peduncles on the test. So, all right, that's about what we can see here without cutting it open. Now let's just take a slice right down the middle. And you'll see it feels like a raw mushroom. That's the consistency of it. Okay, and it cuts about it just as easily. So if I cut this down right down the middle,
Just use your hand.
That's pretty awesome.
okay, right down the middle of the cord. And now that should look familiar.
Okay,
Oh yeah, that's more familiar.
no, there is this
Okay.
is arbor tree. I know that much.
Okay, so if we got it just enough in the midline because we can see the cerebral aqueduct there, so we know we're pretty close to the midline. Okay, but the main features, the corpus callosum, the white matter there. Okay, the one right here is the ventricle. There's the septum pellucidum on this side. Okay, that's the septum that separates the 2 fluid ventricles. I can poke through that, and then I'm going to be into a space there. See, that's the ventricle. Okay, the fornix is right below that. Okay, going front to back right there. And there in front, there should be a little opening. If if I can find it here, where it goes right there. That's the interventricular foramen. That's what lets the fluid get out of the ventricle and go into the third ventricle, which is the space around the thalamus here. Okay? Then it's going to flow down the cerebral aqueduct, down here into the fourth ventricle. Okay? And you'll also notice you see the arbor vitae, right? The tree of life there. Okay? So, if that's the thalamus, okay, what's this area right below it? Hypothalamus, okay, and that's where the pituitary gland is going to be hanging right behind the optic chiasm, okay. The hypothalamus has lots of connections to the pituitary, okay, and the mammillary body again right there, and then as we go over this way, that area is the area right above the pons.
Midbrain?
The midbrain, right, the mesencephalon, right. And so then the rounded area here is the pons, and then the medulla, okay. And what are we missing here? There's the pineal gland, okay. So I didn't cut it right in the middle, otherwise I would have cut it in half, okay.
The boobs of the brain.
We're right here, the brain boobs, the mammillary bodies right here. Okay. Remember, they're in the ventral side. The corpora quadrigemina, the lumps back here, are on the dorsal side. They're on top because they form the roof of that cerebral aqueduct. Okay, so to see them, you have to look at the top of the brain, whereas mammillary body's ventral side. Okay, yeah, a lot of people do get those mixed up. So what else are we getting here that we should know? I think that's pretty much it. But I do want to show you, you know, I've told you that the corpus callosum are commissural fibers going side to side. Okay, so you can better see that or better appreciate that if I put the brain back together like this and then cut it across, do a coronal section like this. Okay. Now you can see the white matter crossing side to side.
And that's the what?
The internal.
The corpus callosum. Okay. The internal capsule. If I cut it back a little further, you probably see the internal capsule with white matter going in the internal capsule.
So to see the internal capsule, do you need to kind of cut it halfway from front to back?
Well, we
not
should
like
be
that.
able, if we cut it back just a little bit further, we should be able to see a strip that looks like internal capsule.
Okay.
There they go. See, you're starting to see fibers run down this way. Okay, it's not quite as pretty as in the human there, but this is the well, what was that body that was right next to the ventricle? Part of the basal ganglia. Yeah, part of the basal ganglia. That would be the caudate nucleus there and over here. This is a piece of the fornix here that's splitting out. Theirs is wider than ours. Okay, but some of this white matter down here is going to be forming the internal capsule as it's running down to the brainstem. So the fibers that are going from side to side through the corpus callosum, those are the commissural fibers. Fibers that are running front to back, are association fibers. Okay, and then the internal capsule is the only one that has projection fibers. Okay. So that'll just about do it. If you can point those things out on the human, you're fine. So if anybody wants to dissect their own brain, you're welcome to it. Otherwise, put these on the grill.
So
Sheep brain, beetle.
this part, when you showed that picture